Assalamu alaikum. This is MATLAB lecture number 4, part number 2. In this part, we will solve exercise number 2 and 3. And mainly, this part talk about how we can use the for loops and while loops in general and plot. Now let me open new script file. As I told you, CLC, clear, close all. Okay. Now, exercise number 2 says that write MATLAB program to save a multiplication result for 1 to 9 in a matrix. That means we have to perform the multiplication and save the results in a matrix. Then we should use this matrix to print the following table as it is. Okay, now let me do some analysis to show you how we can deal with such questions like this. Okay. Let me simplify the problem by using table 4 of 4, not 9, 1 to 9. Say that we have, the first element is 1 by 1, it is 1. Then 2 by 1, it is 2. Then 3 by 1 is 3. 4 by 1, it is 4. So as example, we have say that this is J values, say J values number counter J1, then 2, then 3, then 4. Okay, next and so also we have I values here. It is 1 followed by 2 by 3 by 4. It's 4 by 4. And the result, so 1 by 1 1, 2 multiplied by 1 2, 3 by 1 3, 4 by 1 it is 4. Same thing here, 1 by 1 is 1, then 1 by 2 is 2, 1 by 3 is 3, then 4, 2 by 2 it's 4, it is 4 here, 3 by 2 will be 6, then 4 by 2 will be 8, and here 2 by 3 it will be 6, 3 by 3 it will be 9, and 4 by 3 it will be 12, and 2 by 4 sorry will be 8, and here it will be 3 by 8 12, and here is 16. Now how we can do the analysis, I told you say that we want this line. Okay, now in doing analysis, what I should do, I say that we have here say that here it's J, I name counter J, and here it's I, and let me take example this row when I equal to 2, J will be 1, then 2, then 3, then 4, and the result each time this one it is the I multiplied by J. So we can say that I want my matrix multiplication table matrix. We can say that we need a loop as example. Let me write a loop. We can write 4 starts by row by row. So row counter it's I equal from 1 to 4 like this. This is the end of the for loop. And to go from one line to another, from column to column, we need another for loop. So 4 J equals 1 to 4 also, and this is the end of the for loop. Now what should I do here? It's the most important thing here, the code. Here we can say that we have a matrix where the element according to I and J index equal I multiplied by J, like this. Let me show you. When I equal to 1, J equal to 1, M11, the first element in the matrix, equal 1 by 1. Then J equal 2, I will become, so as example, when I equal to 1, J will be 1, that's it. Then 2, then 3, then 4. Then I become equal 2. Then J will become again 1, 2, 3, 4, and so on until reach I equal to 4. Now this is the first step, how we can save the multiplication table in a matrix. So let us do it here, guys. We can say we need a loop. So a comment here, a comment, save the table in matrix. How we can do that? We need a for loop. We have a counter I for rows equal from 1 to 9 this time, not 4. This is the end of the for loop. This is for j equal to, again, 1 to 9, and this is the end of the inner for loop. And let me remove the space in between here and go up here. Just we can see that multiplication table matrix MTM as example, when I equal I j, it depends on the I value, and j value equal to I multiplied by j, like this, and that's it. This for loop just to save the table. To print it now, Ctrl C. We can use the same for loop to print. Yes, we can use, but I will make it individual step. We can say that I want a comment print, or print, yes, print the table. Okay, how we can print? We need a for loop. Remember that we should print exactly like what in the question. So let me start by how to print spaces followed by 1, 2, 3, 4, 5 until reach 9. We need a for loop surely. So for, we can say that for I equal from 1 to 9 this time. Okay, I want to print what? This is the end of the for loop. I want to print, so if I want to print the value, this value, it's an integer followed by say that 1 space. We can change the spaces later or remove the space, but in width of 3. So like this. And before this one, we have to print space before the line. We can say that I will show you why I will do that later. Okay. Now let me run the program. This is lecture 4 part 2. Okay. Undefined Chloe, what this one, Chloe? Yes, close. Run the program. Okay, I forgot to put the number here. From where I will get this number? This number, it should be the value of I. Run again. See, it will print 1, 9. Okay. First, I will go to next line later, but here I have to keep enough space, so I will print something here. Ctrl C before that. Okay, just space, say 1, 2 spaces, remove the I from here, no need for this one. This is the result, guys. Have space, then 1, 2, 4. Okay, now I want to go to next line. So we can print something here. Ctrl C, Ctrl V, print, go to next line, \n. I will show you the result. I see next line. Now we are in the next line. We want to print what? Space, star, space, followed by dashes. For each number, we have underlined 3 dashes. So again, we want to print the space and the dashes. So Ctrl C. Okay. Ctrl V like this. We can do this one in one step. Yes, I can do that. So we can use 1, 2, 3 spaces as example, remove this one. Same idea. Okay, and this time we want to print dashes instead of numbers, so I will remove all of these. Okay, how many dashes? 1, 2, 3. Let me show you the result. Like this. It's okay. Okay. After this one, what should I do? We printed this one. We want to print 1 or 1, 2, 3, 4. I will forget now. I will focus just on the table. Okay, forget this column. I will do it later. How can I print this one? Surely we have to use a for loop. So here we can write for, say that I equal to 1 to 9. This is the end of the for loop, and we need also another for j equal 1 to 9 to go from one line to another line. this is the end of the for loop. Okay, now why I'm doing that, and say I want to go when I equal to 1, I will print all of the columns in I equal to 1 for the first row. When I equal 2, I will print all of the columns, and so on. And the values are saved in the matrix MTM. Okay, and how can I go from one row to another row? We have to print here \n. So I will print this one, Ctrl C, Ctrl V, but remove the space, no need for it. Okay, what I'm printing here, I want to say that f print f, I want to print the value. Which value this is? It is an integer, and I want to print this integer in width of 3. From where I will get it? From the matrix MTM. Which element in this matrix? It depends on I value and j value. Let me run the program to show you the result. It's okay. But we have a mistake here. Why? After the dashes, yes, we forgot to print a new line. Go to next line after the dashes. So we have to copy this code here, run again. Yes, 1, 2, 3, but we have to remove one space or two. So where is it? This one, yes, we should remove this. Run the program again. 1, 2, 3, okay. Now, regarding this, it's okay. The multiplication table, it's okay. Now we want to print one dash. See here, the one, it's the I value. Here, the 2 is I value. So we want to print the I value in between. So let me go back to here. When I equal to 1 here, I want to print the value of 1. So let me print Ctrl C, Ctrl V. Okay, I want to print same story here. Say that without width. Okay, I want to print the value of I. It depends on the value of I. And after this one, I want to print this sign. Run the program. See, 1, 2, 3, 4, and this is good. But we forgot to print the star here. How we can print the star before the backslash, the dashes here? We have go to 1 space, 2 space, print star, like this. Run the program. See the result. Okay, very good. So this is the program. It's just for loops. How we can use for loops. Regarding the next exercise, exercise number 3. Let me open new script file. CLC clear close all. Okay. We should write comment, but okay. Write MATLAB program to prompt user to enter the initial speed VI. Stop here. VI equal input. Okay. Please enter the initial speed. Say that it is VI in meter per second as example. Then go to next line like this, and I don't want to see the values in the command window. Next, then plot that 2D trajectory. Now, if you remember, I will remind you what is the trajectory for different angles in range A 5 to 100. So let me define A. Say A equal 5 to 100. Say that at the beginning. Let me make the increment is just a few. Say that if I will make the increment 35, I will have 5 and 35, then 70. I have 3 values, never mind, it's okay, just 3 figures. Save the file. This is lecture 4 part, say that question number 3. Okay, now let me remind you that A, it's just not one value. V, it's the initial velocity, and A, it's the angle of projectile. Just remind you what is the projectile. Let me draw the x-axis. So this is the y-axis. This is the x-axis. Okay. Say that we have a projectile, it's a ball or any body. Projectile from the corner or the location 0, 0. It will be like this. It will go to the maximum height, then hit the ground again here. Okay, this is the projectile. If you want to plot this projectile, so just to remind you, this is the y-axis and this is the x-axis. Okay, take this point. If you want to plot the trajectory, we have to take points here. Say that just these points. Say 1, 2, 3, 4, 5 points only. 5 points only. So we want to know the x and y value for each one. Okay, now how we will do that? Now the traveling time for the projectile from here to here, known as TR. Say that we can name it as a TR, and the value, it depends on the equation. I will show you the equation. The equation for the trajectory, it's 2v sine A divided by the gravity acceleration. It is, so we can write it's 2 multiplied by initial velocity by sine of the angle. Say that we'll take the angle, the first angle A, equal just 5. So it will be A here, okay, sine A divided by 9.82, so that we know the first TR. Now what will happen next? We know that the time of traveling it will not exceed more than TR. So we can segment the TR. We can create a vector T. We can say that the T, it's len space, then space, okay. We want the time to start from 0. It should not be more than TR. Say that give us 1, 2, 3, 4, 5 linearly spaced points. So now we know the time vector. Then we have to calculate the x and the y. X, you know that in the x direction the constant is the speed vi, it's constant. That means the acceleration in this direction equal to 0. We know that. And in y direction, we know that there is acceleration, it's minus g. It depends on the traveling, it's up or down. And v, it's variable, not constant. V, it's not constant. So what about x value? X value, the distance, it is the equal the velocity, which is v in x direction, v cosine the angle, which is a, which is 5, or say a, multiply by the time. So all of this multiply by the time. Regarding the y, we have the equation, this equation regarding the y. So it depends on the t also. So we have the equation for x. So now we know x and we know y. Then finally we'll plot x versus y like this. Okay, but this is just for one, the first a. For the second a velocity, it could be like this as example, and like this, and like this, and maybe like this also. And if the angle more than 90, it will be like this, and so on. This is how we can what the projectile is. Let me go back to the question. We defined a. Now, as I told you, we have to each a, we have to find the traveling time. So we can say that traveling time TR equal, as I told you, it is V initial, 2 multiply by V initial multiply by sine. By the way, the sine cosine functions in MATLAB and programming language take angles in radian, so we have to change the angle from degrees to radian, or in MATLAB here we can use sine d instead to use the angle directly in degrees. Sine d of a divided by 9.82, like this. Now v a here, it's a vector. That means evaluating this equation, it will give me a vector also. So let me show you the result of a as example. Evaluate and show you the result of TR. because we have to read the VI also. So let me run the program. Say the initial speed it's 10. Okay, let me write here VI, show you the result, then show you the A. This is the A value, this is the TR values. So when A equal to 5, TR equal 0.1775 and so on. So we know the TRs. Next, you want to find the time. Find the time. So let me write a for loop. Or we can use for loop or without for loop, it's up to you. But I prefer to use a for loop. Say I have a counter equal from 1, from 0 this counter, or from 1 to length of A. So we want to work on the first velocity in A, then next one, then next one. So how many values in A we don't know, and I should not know or count them by myself. Let me let the program, the MATLAB, find the length of A and run a loop from 1 to length of A. If A 5, that means from 1 to 5. This is the end. Okay. When I equal to 1, I'm working on the first value of A. We want to find T. T equal what? The time equal len space to create a vector with linearly spaced values. It should be start from 0. It should not be more than TR. Which TR? For the first one, it will be I1. So it depends on the R and the value of I. When I equal 1, TR of 1. So we know the, I forgot something here also. It's from 0, it should not be more than TR of I. So from 0 to TR of I, say that I want just 50 points in between with 0 and TR included. Now we want to calculate X equal say VI multiply by the T multiply by cosine D of the angle A. Which A? A, it depends of I. So the first A, second A, it depends. Semicolon. And same thing for Y. Y equal VI multiply by T multiply by sine D this time. Sine D of which A? It is the A, it depends on the I value. Okay. And then minus 0.5 multiply by 8.2 multiply by T to the power 2. T to the power 2. Now T, it's a vector. We should not write T to the power 2. T dot to the power 2 to make it element by element. And this is what we want exactly, element by element. We know the T and the X and Y now done. Next we want to plot. Say plot. I want to plot X in X-axis, Y in Y-axis. Okay. And say that we want to plot it as a stars or as just make the color. By the way, the color could be, we can change the color, by the way. Say that we can write color of I. Color of I. So when I equal 1, select one of the colors. When I equal 2, select different color, and so on. If you want to keep all of them, all the graphs, I will show you the difference later, okay? So let me write here X label, Y label, grid on. So title, we can write the title here. The title, it is trajectory. Okay, the X label, we can write X. The Y label, Y. I'm sorry guys for my voice, I'm a little bit sick. Okay, Y. And also grid on. That's it. Okay, so we will get actually we should get it depends on number of A's here. You have A here 3 values. We should get 3 plots, but we will get 1. I will show you why. So say that the initial speed it is 10. Length, I'm sorry for this mistake. This is length. Run the program. This is 10. Error and plot. Error and color line type argument. Color line type argument. Okay. Okay, I will solve this one. I remember we can write the color like this, no problem. But let me think what's the mistake here. I forgot, maybe we should like this, write it again. This is 10, undefined color, same problem. So let me say that I want it as like the following. I want it stars with color of I, 10, undefined color, I don't know. Let me change this one. Maybe no, it will be when I equal 1, it should select one of the colors. I don't know, I will check it later, guys. Okay, so we can say that I want to print them in blue as example, like this. Run the program again. This is 10. Okay, yes, but why we got just 1? Because we didn't keep hold on. So before the for loop, hold on, because the last print, the last plot will delete all of the previous plots. So keep hold on. Now run the program. This is 10. So for 10 we have just 3. Okay, now let me go to A and make the increment is 10 as example. Show you what would be the result. This is 20 this time. Okay, this is, as you see here, one of them to the left. Why? Because we reached 100 or 95 maybe. Okay, for the 95 the angle it's more than 90, it will go to the left. So this is the trajectory, how we can plot, how we can do everything. It's very simple code. So just let me check how we can change the color. When I equal to 1, select let the MATLAB select one of the colors. I will check the code and edit the code. I think I remember now. I forgot a step here. Again, plot xy. I want to plot with color. Say that color of, it depends on of I. So when I equal 1, select the color. But this is a vector, should be defined before. What this color? So let me say that I want the color vector equal a string. What is string? Say that for red, choose R, C, M, G, blue, green, yellow as green, yellow, red, blue, and so on, black, K, and it depends on how many angles here. So we don't know exactly. So it may repeat, make it strong or longer string like this. Just copy and paste them again. So we have, I don't know exactly what's the length of this color. We have many colors. Now let me run this code, show you the result. When you run it, evaluate, you will get something like this. See color, we have many characters here. We have many characters. Now when I equal to 1, it will take the first character in the color. What's the first one? R. R, that means red. It will print it in red, and so on. Let me run the program. Say that this is 20. Oh, good. See? The first one red, and so on, and so on, and so on. So it depends on the character selected from this string. So define the vector color like this, and take, it depends on I value. When I equal 1, take the first character. When I equal 2, take the second, and so on, and so on. So this is how we can change the color automatically in the for loop for a plot. Thank you so much for watching this video. See you in the next video.